Yeah, hi everybody. My name is Paul Keely. I work for a company called Born in the Cloud. I'm a 10 times MVP. Started off in SCOM. I've been an Azure MVP for 6 years, and all I do is focus on security. And only focusing on security, I can't keep up. That's all I do. So if you have that proverbial drinking from a fire hose experience in Azure, focus on just one thing and it'll feel a little bit better. This demo has a ton of moving parts today, a ton of moving parts. And the title of the demo is, or title of the talk is using Sentinel or building a modern SOC with Sentinel or something like that, okay? And so what I'm going to go through is I'm going to go through some attacks. I'm going to go through Sentinel, which is a SIEM, like it's not a SOC. I'm going to go through it, and we're going to talk about the SIEM capabilities, the SOAR capabilities, and how we have built that into a SOC and what you might consider in your organizations. So a SIEM is a security event and incident management tool. What does that mean? I'm going to go super basic, and then we're going to go pretty steep uphill. So what that means is throughout your environment, when people do stuff, we log what they do, and we pull that to a single location. We look at what's happening on the single location. Hopefully we're able to find problems. And so that's what a SIEM is, event correlation, creating incidents out of events. Now, what's a cloud-based SIEM? Hopefully you got the picture by now. You're not installing anything on-prem. It's basically an hyperscale, I would say infinite scale, security logging tool. And then within Sentinel, it also has SOAR capabilities. So SOAR, sorry for all these acronyms, but we all love acronyms: security, orchestration, and automated response. The ability to actually take action straight away when we see something happen, okay? And then the SOC is the process, it's the people that look at your SOC and at your SIEM and decide to take action throughout the environment, okay? How does Sentinel work? It starts off with a log analytics workspace. Lots of things in Azure start off with the log analytics workspace, and then you place lenses on the workspace. So one of them is Azure Security Center, which really is a compliance tool. It looks at how things are set up and if they're compliant. And another lens you can put on a log analytics workspace is the Sentinel lens. Believe it or not, you can deploy a log analytics workspace from PowerShell, and you just add a solution called Security Insights, and boom, you end up with Sentinel. That's all you have to do. All right. So we have a log analytics workspace, where we can put, supposedly infinite amount of data, and then we have to get data into it. So how do we get data into it? Well, there's a bunch of out-of-the-box connectors. You can see that there's 39 connectors. And this typically allows us to connect to things like, Amazon Web Services. Obviously, the Microsoft stuff is pretty strong. And, Barracudas, checkpoints, F5s, etc. So this really allows us to pull in lots of tools. Most of the networking stuff, it just comes in through syslog. Right, just comes in through syslog. Pretty ugly, but I'll show you how to deal with that in a second. So we started off, we've created the log analytics workspace. We've set up a bunch of connectors and they've pulled data in. We can also go and put agents on machines. And when I put agents on machines, the log analytics agent, the MMA agent, that pulls data in. And then the last thing we can do is we can do custom ingestions. I would say 60% of our work is doing custom injections, and I'll show you some on our prod environment. So we've pulled data in, and then the next thing is we want to have analytics, stuff that's actually going to go and look at the data and come up with a problem and say, hey, you know, I see a problem. All right. And so Microsoft have their own templates that they use that comes with it. And, you know, to give you, like, I always focus on this one super duper one called Microsoft Fusion. And if you look at this, what this is Microsoft go and they use machine learning on the data in your environment, and they take tons of warnings, they combine them together, and they go, oh, actually, that's the problem. Boom, right just there. And so if you look at just this one connector, it, you know, here's what it does. It actually does 36, looks at 36 data sets, processes what it sees, you know, and says, oh, this plus this plus this equals a problem. All right. So, and then one of the things that that you will do, or that we do, is we go and we write our own analytics. And an analytic is, hey, I want to go and understand what's going on in the environment. So I'm just super quick going to show you. This is an old analytic that we used, but wrong one. This is an old analytic that we used, but it will probably ring home for lots of people. So the worst thing that we want in monitoring, definitely for security, is pulling data from a single data source. I used to work in SCOM all the time, and SCOM had this security management pack, and it said, oh, if event ID blah 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 happens, create a critical alert. And we're like, Jenny Mac, are you kidding me? Like one thing happens and you're going to create an incident, and we end up with something called alert fatigue in the SOC. We were working for a government department in a country I won't mention, but it's under a lot of cyber attack. And they've 1.7 million new incidents in their SOC. They've given up. They just like, you know, there's no point. We just can't deal with stuff anymore. And so one of the challenges with lots of Microsoft first-party tools, like Cloud App Security, is they look at two data sets. They say, oh, a user logs in from two places in a certain time period, we got a problem, all right? And we intensely dislike this as a security alert. Why? Because somebody logging in from two locations, you know, like that's not a high fidelity alert, right? And so if I just show you, let me just drag a slide over here for a sec. So when we look at things like impossible travel, here's the most common impossible travel. A user, hopefully with your machines registered in Azure AD. I can't stress enough, please everyone do Azure AD hybrid join as the most basic thing you can do. Any user, any device, any app, anytime is awesome advertising. It's terrible for security, right? Knock that on the head right now. We can't use it. We can let anybody go to crappy little apps and, you know, request holiday time or something, but people can't go and access your ERP and your HR and your finance and your PPI data from any old device anywhere in the world. Like that is just a no-go. That flies in the face of any kind of zero trust model. So this here, you know, a user, one machine in Azure AD, 2 IP addresses, all right? Well, in Cloud App Security, you get an alert for this. But we think that's a terrible alert. And this one here, 2 geographically displaced or dispersed machines, 2 IP addresses, again, you get an alert. Since COVID-19, we've deployed 11 WVD solutions to hospitals in the US. So I'm sitting on my device, I log in, then I virtual desktop into a virtual machine. Bang, I've got another IP address when I've connected to portal@office.com. The important thing is both of these devices are known. Why am I, and if they're compliant, why am I getting an alert? And this one here is the bad boy. You know, a device that's known in Azure AD, a device that's unknown, yikes, I want to know about this. And so the most likely reasons for things like impossible travel is a user walks into an airport lounge. This happens to me all the time. I'm in America. Used to be in America a week, a month. I'm in, Dulles in Washington, D.C. I walk into the BA lounge. 5 minutes later, I connect to the Wi-Fi, and I'm somewhere north of the M25. Boom, impossible travel goes off, right? And I'm going to show you a real nice solution for this, but one of our CTO in Born in the Cloud, they went to the Inspire conference. I think it's Inspire in Vegas. Gets off the plane, opens their iPhone, goes to the conference, joins the conference, and now they're in Seattle. We get an impossible travel. Okay, and what we do is we have a vetting system that sees what's happening, and then when the next 10 people come, nothing comes true. So what we would do in this situation is we would go and grab the Intune registered device data set. We'd go and grab the Azure AD data set, and we'd find the device ID. And then we do a bunch of joins. And then the very last thing we say is, hey, take impossible travel, take the sign in, blah, blah, blah. And if you find a device that's not compliant, right, and any device that's unknown, that's not an Azure AD, automatically becomes, non-compliant because we don't have compliance data about it, then give me an alert. But go and check 6 data sets first before you go and give me the alert. And then one of the other super awesome things that Sentinel can do is, in my demos now, I'm going to be getting logic apps to run, but you don't have to get the logic apps to run. If you have super confidence in what you see, you can go and make the logic app fire instantly, like within a second, okay? And just to point out here, S1 is Sentinel-1, non-Microsoft antivirus. If you look here, you should see Zscaler. You should see lots of other stuff that we build logic apps for. Go connect to VirusTotal, go to connect to Sentinel-1, go connect to Zscaler, and we do things throughout the environment with logic apps. This is probably the #1 differentiator between Azure Sentinel and most other SIEMs, is that Microsoft, you're plugged straight in to the matrix of awesome tools, that logic apps. So if you were to say to me, what's a logic app? It's the actual first Microsoft automation that works. For about 10 years, I banged my head against Orchestrator, System Center Orchestrator, pile of crap. It was server-based, SQL-based, service accounts. Man, somebody patches a server, it goes down, forget it. So logic apps, man, they just work and they just continue working. All right. So there's more to it, but I'm just going to take that. We're just going to take right now, user does something. We have a connector to pull the login. We have analytics that see that there's a problem, and we've playbooks that take action. Okay. So we're going to start off just by hacking a user. So I'm just going to go. I get this, web page. Everybody can see up the top. It's Azure websites. We wrote this. It's absolutely not a Office 365 sign-in page. But I send it to somebody. They hit next. They put in their password, and they hit sign in, and they just get brought to a fake sign in page. We've a production version of this app that the first page was username, second page was password, third page is your MFA code. And if you enter an MFA code, a 6-digit code, we replay that, and boom, we're in. And to say life is good is the understatement of the year. And then just before I do this, because I'm a big believer that telling ain't selling. If I don't see stuff in real time, I don't believe it. So here's what we're going to do. Here's what I'd like you to imagine is that we have gone and hacked this. We've gone and successfully fished sec user 1. And I'm going to try and fish more users and move throughout the environment. All right. And so what I want to find out is, can I find password sprays? Can I find a user breach? Can I see what's happening through the org? And can I automatically go and do stuff? So for example, in the Exchange Admin Center, in connection filters, in connection filtering, I've no IP list, all right? But what's going to happen in a few minutes is I'm going to go fish a user. I'm going to do a password spray. We're going to see all that, and we're going to rain hell on the people who are doing it. So that one, yeah, okay. So here's what we're just going to do for a sec is I've just gone and fished sec user 1, all right, which gives me access to a BITC demo, all right? And I'm going to use a tool called OO365 Recon, public tool you can just get online in GitHub. And then what I'm just going to do is I've gone and done an exploration of users, and then on the exploration I'm going to try a password spray. The important thing to understand is that I'm using the Exchange Web Service. Why am I using the Exchange Web Service? Because it's an online version of Exchange 2010, right? Why is that important? Because it doesn't use MFA, right? It doesn't need me to go in on MFA. And so what I'm doing is, and just be totally clear, I'm passing a password to a script and I'm asking it to try the password on a bunch of users, all right? So a modern password spray is totally different to a password hack. A password hack is typically me trying 1 million words on one user account, but a user account locks out after 5 or 10 passwords. A password spray is me trying a password, just guessing something, right, and trying it on 1,000 users. Then I wait for an hour, and then I try again. What happens in that hour? You open Outlook, you open your phone, you re-authenticate, and the bad password count resets, okay? And so you can see here, so what should we know straight away? I mean, first of all, there's a whole ton of users who are failing to log in, right? And then one user successfully logs in. So this is a password spray. You know, there's no good reason why 500 users in your org fail to log in, except, you know, password spray. And then the second one is, well, okay, this is a bad Saturday, right? You know, and then it becomes a crap Saturday because sec user 2 was successfully logged in after all those users failed, right? So if I just go here and I say PORT, portal.office.com, and, you know, I'm logged in as sec user 2. Now, I don't know if you need me to show you that sec user 2 is enabled, but like, you know, like I can't get here if the account, you know, isn't working. And then the last thing that we want to see is, you know, what's the IP address of this machine? It's 4083.9.2. Okay, so what do we now know? Well, we have the public IP address of a machine that's trying password sprays, and we have a user that has been successfully breached from this IP address. Do we know it's a breach? Well, we don't. Are we pretty sure it's a breach? Yes. Right. What are the characteristics? Well, this device is unknown in our org. You know, a whole ton of users have failed to log on from that IP address. You know, if it looks like a dog and barks like a dog, it's a dog. Okay. And then the next thing that we're going to imagine is that this user, like we're starting to have a hard time with this user, right? And so maybe we do things like we log in as sec user 1 or 2, and maybe we start sending emails to people in the environment. Now, here's what I'm going to show you first of all is Chrome is working just fine because we're going to stop Chrome. We're going to block unsigned apps. And second of all, when I go and I open WinIntro invoice.atp and I open this is a Word doc that has a malicious macro, and it's running this WinIntro backdoor.jpg. Okay. Now, this is running, visually, or it's running in the foreground, and you can see it, and it's making connections to other environments, and it's trying to pull down a much heavier packet. Okay, and that's bad news. And then it finishes by having an admin command prompt. So let me just show you this again. It's super important to understand. I'm going to double click the Word file. All right. Now I've already enabled the macro. Unfortunately, when I do that once, the macro is just always enabled, so I can't show you this. But every time I do this, this malware loads. Now this in your environment will be running in the background. All right. And so what you're starting to see is somebody breaches a user, they breach another user. They're starting to send, phishing emails. We start to trust them a bit more. They're doing more, they're doing stuff throughout the environment. And I'm trying to laterally move throughout your org. I'm trying to get in and basically become a pain in the ass. All right. And so what we want to be able to do, sending something on a Word doc, on PDF, this is a classic living off the land attack, because every user uses Word, every user uses PDF. If I were to ask you to smile and think to yourself, how many times in your life have you said, oh, should I enable that macro? And it says, well, if you don't want the feature, you can't enable the macro. And you say, Ashley Jays, go on, and you enable the macro. And most of the time, nothing happens. Most of the time, nothing happens. But what I would love to be able to do to this machine is I would love to block unsigned code. Right? That malware is not signed by Microsoft. If a malware is ever signed by Microsoft, then good luck. You can give up now. And Chrome is not signed by Microsoft. And so when I show this to people, they say, oh, but our custom app won't work. Like, dude or dudess, you're being breached. You are wholeheartedly being attacked right now. The fact that somebody can't get to a custom app, bad luck. We have to stop them moving. All right. And so the most simplest thing we're going to do is we're going to go in through an API. We're going to block this machine working, and then we're going to isolate the machine, and then we're going to come back in. Now, what I just want to show you what this looks like in real life. So here is the machine overview. Here's Win10C4, and you can see restrict app execution is ready to be fired. An isolate machine is ready to be fired. But man, I don't want this to I don't want to go there. I want Sentinel to do this. I've no interest in a user knowing where all this stuff. I've no interest in a user knowing how to get here. I want Sentinel to know how to do it. Right? I want this all written into Sentinel. So when I go into my incidents and I just refresh, now it does take, here is the user breach, and here's, a bunch of failed logins. So collating, failing and successful sign-ins. And so, this is not a good news story. Japers, this is not a good news story. And if we give it a couple of minutes, the Defender ATP is going to pop up. I'm doing all this in real time, right? There's no, there's nothing up my sleeve in this. This is happening in real time. I'm in France, by the way. So if you're saying, hang on, this is 119, that's why it looks like that. So if we just go in for a sec and we, what will we just go and have a look at? So if I just go user fail breach, okay, there's a count, and we just go in and we look at the details of this, and we look at the entities, okay. So it's after finding a good few people. This is a demo environment that, has a ton of people doing things. So let me just see if I can go in there and add a few details and entities. Okay, I've still got them all. Here's sec user 2. All right. So the first thing that we're going to do, we've kind of no choice. Let's just go in on the first one. So the first thing that we're just going to do is I want to be able to go in and shut down sec user 2. So let's just have a quick look. Let's just have a look at what we see. We have an event, okay? And in the event, if you look here, it says, hey, look, you see all these people, they're after failing to log in, right? You know, but then what? Well, unfortunately, a bunch of people are after successfully logging in from that environment. Okay, sec user 2 is one of them. And, you know, you're like, yikes, we're in a bit of trouble. You know, what are we going to do? All right. And so what we're going to do is we're just going to go to our playbooks. And on our playbooks, we're going to say, hey, you know, let's just go and disable those user accounts. Now, this is problematic. We're pretty nervous about what we see, okay? And so what are we just going to do? You can see there, here's our secops blockaccount.org, okay? And I'm just going to say, fine, let's do it. Boom, playbook has been triggered. Playbook was successful, okay? Now, pretty much instantaneously, okay, not saying instantaneously, but very quickly, that runs and that starts to cause a fair bit of grief to those people. A fair bit of grief as in it starts to shut them down. And then let me just refresh that again. So and there's our password spray, okay? So in our password spray, let's just go into this and let's have a quick look at this and let's view the details. And on the password spray 1083.9.2, all right? So just in case you are forgetting, you know, 4083.9.2. That's what yeah, 4083.9.2. So look at the events. And what the event is saying is it's saying, hey, look, see that IP address, 4083.9.2, man, we've got a ton of people failing to log in, you know, invalid username and password. Why are they failing to log? Why are all these people failing to log in? And it's a password spray, you know, period. It's a password spray. Okay. So what would we like to be able to do? Well, I'd like to start blocking that IP address. Okay. So alert, view playbooks. And sorry, stuck for this run. And so, you know, once again, I'm just going to block this IP address at the org. Now, I'm doing this because I want you to see, Japers, has Bob broke Azure? I'm doing this because I want you to see the flow of the demo, right? And most people for us, most people in our environment do not get this to run automatically for a bit. Their SOC or the IT security lets it, you know, does it themselves for a bit, and then they say, okay, you know, let's do it. And so you can see here, Sentinel block IP at the org, and I'm just gonna hit run, and you know, triggering the playbook, and hopefully in a second that's just going to turn around and say playbook ran successfully. And okay, and then things to understand, guys, is we do things like somebody on a network security group in Azure sets up an any room. Man, we see it, bosh, it gets pulled up. You know, sometimes there's not many reasons, but sometimes we have had people with an NSG putting in an any. And you know, Sentinel has gone and ripped it out. It's caused them grief. You're like, why is this testing failing? And they've had to come to us and say, hey, you know, every time we do this, your bloody Sentinel keeps stopping it. And I'm like, well, why do you have a firewall with doing no firewalling? You know, why do you have an any? Oh, we're doing testing or whatever. You know, okay, fine. So they're going and blocking right now. And then the next one is if, oh, trigger failed. Okay, I'll come back to that in a sec. Let me just refresh one last time. Collating. So the Defender ATP can sometimes just take a little bit of time to kick in. So I did one just before. So here's the Windows Defender ATP. I did this just a few minutes, like you know, I did it before I was doing a test. If I do a refresh, will I just see if the latest one comes in? Okay, hasn't just come in. Let's just hang on a sec. So I'll run it from the test I did just in building my you know, practicing my demo before this. So you know, here's the Defender ATP. When I go into my view alerts on this, and then what I'm just going to say is, so what it's going to say, look, here's the events. And what it's going to say is, hey, we're seeing a bunch of stuff. That's actually Solar Sailor. Okay, that's another one. Somebody else working on it. I'm going to just have to give it a minute and see if I just give it a couple of seconds, will it just come in? No. Let's just go back to password spray. And on password spray, let's just try and invoke that notebook. So what we're going to do, password spray. Oh yeah, block IP at the org. I don't know why that's doing that up top. It shouldn't do that. Where are we? Block IP at the org. Run, trigger playbook. Okay, boom. Playbook was successful. I don't know why there was a challenge with that just a second ago. And then here is the, what we're just going to have to wait a couple of seconds for the Defender ATP to come in. And when that comes in, we'll go and run a block on it. And then if I could just go down to ATP, so ATP. So if I could just explain, so what you can possibly say to me is, hang on a second, you know, this is just a plain Microsoft tool. You know, we're not using ATP. I mean, we are just calling this on an API, right? So it doesn't matter to us if we use Defender ATP, if we use Sentinel-1, if we use CloudStrike. You know, we are just going in on the API to do the you know, to go in and do the actions on it. So like, it's not out of the box. So I just in events, I'm looking to find Win10C4 and not Solar Sailor. What it's finding, Solar Sailor. Okay, I'm just gonna have to give it a couple of minutes. And so, you know, what we should start to see if we go and we look over here. So what we should start to see on Solar Sailor is sec user 2. If we refresh sec user 2, okay, let's give that a sec. Oh, sorry. Okay, so that just hasn't run just yet. Let's just give it a sec to kick in. So just on what I've shown you so far, while we're just waiting on these to kick in, does anybody have any questions? What you've seen so far? Anybody want to ask me anything?
If anybody does want to ask a question, please feel free to take yourself off mute and ask, or you can pop it in the chat window. I do have a question for you also, Paul.
Sure.
What would you say is a key selling point of Sentinel versus other systems?
Well, so the automation, I'm just checking the automation to see that has, so as far as I can see, that has actually kicked in. PORT portal.office sec user 2. Okay, so what I could see is I can see that logic app running, and then if I just go here to the connection filter. So I just refreshed the connection filter, and when I go in and I look at it, if you look at connection filtering, there's 4083.9.2 put in, and then if we go here and we look at sec user 2, sec user 2 has been blocked in that time period. So we manually went and called the automation to go in and do it, but we didn't have to. I mean, most people, if they get if they get a feeling of comfort with it, where they're like, hey, we're just going to let it run, some people are happy to just go and do it themselves. Some people will just let it run automatically, like that. And then here's a couple of things on the automation. The playbooks, so one that's just blocked the IP address, one that's just blocked sec user 2. For me, the difference or the selling point in this is that I don't have to have permission in Office 365 or in Defender ATP or in Sentinel-1 or in SAP to run them. The credentials are inside the Logic app. Like, why is that so important? It's so important because your SOC team don't need to have permissions throughout your org, right? It means that if you have a remote SOC, that they don't need permissions, that they can call a Logic app in your environment and it can go and stop somebody, and they didn't need the permission in that environment. And then B is the, Microsoft stack alone is enormous. To expect somebody to be able to find where is something in something, how do I go to Azure and find the NSG and stop, find the network security group and find the NEMU rule and rip it out? Where do I go and find a mailbox rule that someone's put in? It's too complex and it's too vast. And so having automation that can do it for you is pretty killer. So
we do have another request, Paul, on the chat. Can you go back to the rules you have created? What language are they written in?
Yeah. Okay, that's a great question. So let me just go into prod and show you this in our prod environment. I'll show you some easy stuff. So the language that they're written in is KQL. KQL, if I don't know if Bob Duffy's on this, but KQL is kind of like badly written SQL, is how SQL snobs call it. If you're good on SQL, you'll understand KQL. If I just show you in our SOC here, so the language is it uses an IntelliSense. It uses a lot of plain English to go and find stuff. And so if I just go SI and I want to find sign-in logs, it shows me the sign-in logs. And I just say where what user principal name contains Paul, and I just hit go, and then it will go and find all the sign-ins for me in the environment. And then I say app display name. App display name contains sales. Okay. And let me just put that out to last 7 days, and I hit go. And now what you're going to see is here is me signing into Salesforce. Okay. And this is the sign-in log. This is just one log from Sentinel. Right? You need a P1 license for this, but this is one log. So have a look at this. And if you can find this anywhere else, good luck. So this is just one single log. It says, hey, look, Paul, who's in France, has logged into Salesforce. There's the app ID. And then it will show you the conditional access policies, and it shows you the policy we have for Salesforce, and I satisfied 3 conditions. The 3 conditions are MFA is enabled, my device is compliant, and my sign-in frequency. Okay, so it shows you the conditional access policies that were successful. And then it shows you my device details. It says, hey, Paul came in on Surface Book, it's compliant, it's managed, it's trusted by Azure AD. Okay, so it's able to go and find that data in the login, and then it will say, there's an IP address, there's his, where he is, and then it goes to the intelligence security graph. So Microsoft only make these signals available to Sentinel, and it says, what was Paul's risk score during sign-in? Now, lots of people have no idea what this intelligence security graph is. Most people in Microsoft either don't know what it is or have a terrible way of explaining it. And all the ISG, the intelligence security graph, is a hyperscale threat intelligence library. That's not all, but that's fundamentally what it is. And this is an app that we've built to visualize. This is us just calling the ISG for BITC demo. And you can see that the providers are, Azure ATP, Security Center, like Defender ATP, Identity Protection, Azure Security Center, Sentinel, and Cloud App Security. And then in the categories, you can see you have risk score. All right. And then if I just show you here, if I just show you top 10 and I go here. So what the ISG will show now is, it's seeing a bunch of stuff from Azure Security Center and threat protection. If I went to 100, there's a good few people using this. So I'm trying to see if I can get the ATP, the ones I would have had on ATP. Okay, it's gonna have to go through the pages. So, here's my Defender ATP. So like, there's the suspicious PowerShell command line, has been run. And if I just go in and I have a look at it, this is what's going to be in Sentinel in a couple of minutes. And so it will say, look, PowerShell dropped a suspicious file on a machine. Ron HD on BITC demo. Has this file accessed. So if we just spin back here, look what it's pulling in. It's showing all the risk scores, and then lastly, it's showing my MFA status. Now, what does this mean? MFA required satisfied by token. It means I didn't actually MFA. It means ages ago I MFA'd. And since then, I've clicked the keep me signed in token, KMSI, right? And so we will parse this and give this login a lower security rating because they didn't actually log on, at this time. They didn't MFA at this time. And if I just show you here, if I just go in and I say, if I just get rid of the and Salesforce and I drop in and browser conditional access success. If I do one of them and I scroll down, okay, there we go. So here is where. So let me just show you this. This is super important. Is it says. Here's me trying to get on, and it says, user did not pass MFA challenge. Okay, have a look. MFA required. User did not pass the MFA challenge. all right? And so you can see nothing else was applied in this environment because it didn't get on, because it didn't pass MFA. And what you can also see is that the device details don't show anything. You know, device ID, it shows this ID, shows the browser. It doesn't show that I was compliant. So what that means is that this device is unknown to Azure AD. So what does that mean? That means you've just caught this problem. You know, someone's tried to sign in, the device is unknown, they've already signed in somewhere else. Yikes, we're in trouble. All right. And then one of the kind of things that we spend most of our time, you know, working on, and the reality is that if you're going to implement this in anger in a big org, you are actually either you're going to be brilliant in lots of things or you're going to need a little bit of help with it. But one of the things that we do, you know, because we work on impossible travel a hell of a lot, and one of the things that that we will pull in is we will go and write queries. And so let me just expand this. Let me just drag this down a bit. And so in this query, what we're doing is we're going to security alerts. Why are we going to security alerts? Because I don't want MCAS to stick a security alert into Sentinel. All right. Let me just explain what I mean by this. Is that inside the MCAS connector to Sentinel, I tell the connector, hey, do not bring impossible travel alerts in. Why? Because I'll build my own impossible travel alert. Why? Because MCAS is using too few data points, right? So if I show you here in the connector, and I go into Cloud App Security and I open the connector page. So, sorry, not the connector, dang. If I go to the analytic, and then on the analytic, if I go to the Cloud App Security and I show you this, you'll see that we say exclude impossible travel. Why do we say exclude impossible travel? We say exclude impossible travel because impossible travel is giving too low fidelity an alert because it's only pulling one data source. Why is there only pulling one data source? Man, it's only a first party tool. This isn't where you do the correlation. You do the correlation in your SIM, right? So here's Paul logged in America and in France. Oh, I'm going to give you an alert. No, you're not. Why are you not going to give me an alert? Because A, we go and we find the impossible travel activity. Then we look at the IP addresses, okay? And then from the IP addresses, we then go into sign-in logs and we look for, hey, when the user signed in, is the device compliant? Is it known to us? Have we seen it before? You know, is it in our safe list? And only then do we allow an impossible travel alert to be created. And if I just show you in here, in Born in the Clouds, like this is our production environment. So we've one incident. If I show you in the last 7 days, we've had 4 incidents in the last 7 days. And we actually did stuff about this. Why? Because we use much more data sources to look at something to say, do we have a problem? Okay. I know I'm going to just bomb through this. Sentinel has this thing called a Jupyter notebook. Jupyter notebooks are typically Python notebooks that connect to your Sentinel environment, pull the data out, and allow you to apply much richer libraries to the environment. Got it there? Okay. So, one of the things that we do is we do things like we will take, let me just go to a host score. This makes most sense. Okay, in a host score, so let me just explain what we've done. We connect into log analytics, all right? We grab some libraries like NumPy, Panda, Metasploit. These are open source libraries that help you analyze data in a deeper sense that you can just do a plain old log analytics. This is just taken from my log analytics workspace. I'm just putting a bigger lens onto it. And then the first thing we do is we look at link status on a device. And we're trying to see, is there more failed links than passed, right? Typical sign of somebody doing reconnaissance in your network. We look at latency. Is a link going somewhere and it's taking a long time because somebody's not in the building, they're connected in? We look at all of the alerts on the box and we give it these scores. Now, one of the questions we had is what makes Sentinel different? What makes Sentinel really different is that the machine learning that we build in Sentinel, that companies build for you, you can break open their workbooks and see what people are using and see the scores that they're giving, and you can go in and change those scores, right? Why is that a big deal for you? Because you might say, hey, I want more emphasis on this than on that. And so in the machine learning that we use, there's two things that are important. One, what's the answer? And two, how'd you get the answer? And we're able to show you how we do the scoring and how we get the answers. We look for suspicious processes. We look at threat detection. We go and look at malicious IP. We do performance checking on the box. We look at the build version. And we give scores based on how old it is. You might say, no. Anything below like last year, that gets a real low risk score. And then we go and we show you if there's missing updates on the machine. Okay. There's this one I find super depressing. This is on Born in the Cloud's actual Office 365 data. So if I want to breach one of your environments, okay, and I get into your mailbox, the first thing I have to do is search. I have to do reconnaissance. I have to say, oh, what can I find? And I have to go to SharePoint and do reconnaissance. And if I asked everybody who's listening to this, how many times on a Tuesday at 11 o'clock did you search Outlook? And you will not know, and you can't. But being able to look at the trends in your data with tools like this, we can find out, oh, it turns out Paul's done 35 searches of Outlook today. Has he ever done that before? No. How do we know that? Because we go and we analyze patterns in the data. And I said I find this super depressing. What I find super depressing, sorry, let me just go up to the SharePoint bit, is because I'm one of the founders in Born in the Cloud. So like this is exchange item, but when we went and they drew this out for me, I thought, oh my God, I need to kill some people. So this is SharePoint activity in our org on average in a week, right? Nobody does anything on a Friday. People don't do a whole lot more on a Monday, and everyone works like crazy on Wednesday, do a bit more on Thursday. This is our SOC on a Sunday, but man, Monday and Friday, everyone's just getting ready to party on Friday and everyone's recovering on a Monday. So we're able to go in and find, what data looks like in the environment. And we do the same for things like IP validations, host scores, etc. Why is this important? This is important because there's my app. Because in a SOC, you are trying to risk score what's going on in your environment. All right. So the SOC is the physical process, the people who are there looking at what's in Sentinel and trying to make decisions to say, is this bad, yes or no? All right. So what we do and other people like us do is we build these models, all right? And we put them into an API, something we call a Flask app, and then we build an interface where we can go and query something. And if I just show you here, like we build these for different companies that we work with, but I'm just going to run this for Born in the Cloud. I'm just going to, so this is looking at the user. So it's looking at a device. A risk score on a host. So when I go and I hit execute and this runs, that's going to that Python in the background. It's checking the 50 things that you see, and you can see that this machine gets a confidence score of 0.8. That's a really high confidence score, okay? And so, an alert comes up to say, Paul, on this PC went to that IP, we think there's a problem. How do I know? Well, I can go and risk score the host. I can scroll down here, all right, and I can go and risk score the IP address. So this is my IP address right now, 83, blah, blah, blah. I can hit execute, and this will go and run the risk scores on the IP address. You know, it's marked safe. And then lastly, I can go and risk score a user. I can go and risk score Ryan. And so, you know, if you look at this, in about 10 seconds, we go and we get these risk scores back. All right. And the key thing for that is that we're able to add more information into Sentinel. This gets written back into our ticket. You know, it says, hey, you know, we saw this when we see like a risk score, everything that we've seen, the scores are low. As far as we're concerned, this is not a problem. You know, Cameo boots, we don't see a big problem with it. So I know I'm, yeah.
We're getting very close to being over time. Is there anything else you wanted to close with?
Is there any questions?
There's nothing else in the chat window.
Okay, if I could just for the sake of completeness, like we did this attack on Defender ATP, and I've just got a couple of seconds to go. And there's Win10C4, you know, what we saw all this attack on. And so if I just go to my playbooks and just super quick, if I just go to app restriction, if I just go to app restriction and I just say run, and essentially what I'm doing there is I am stopping apps run. So that, like this, yeah, there's a little message comes up when I try and open Google, boom, you know, it won't work. When I close this and I reopen it, you'll see it will open, but the PowerShell script won't open beside it because it's not signed. We've done the app restriction. And then just the very, you know, that doesn't come up, and we saw it come up 3 times. And then just very quickly, my last one is I'm just going to go and isolate that machine. So I just hit run, and I'm just going to show you this in real time. Look, I've already lost access to that machine, and that machine's sitting in Virginia and I'm in France. That happened in 4 seconds. So, you know, it sometimes takes a few minutes for the stuff to come in, but we can respond super quick, and boom, man, I've just lost it completely.
Paul, this has been an excellent session, and I think everybody attending can agree that this stuff is not just important for those larger corporates, but this really applies to everybody. And I think that's been an excellent overview of everything. It was fast, so
yeah. Sorry, I had a lot to cover in an hour. If you want to ask a question, yeah. Paul at Born in the Cloud, you can get me there.
And we'll also have this session on YouTube as well afterwards. So we'll put in some links there to come back to you. Any blog or other data that you want to give us as links, that would be awesome.
Yeah. So thanks very much for giving me some of your Saturday. I hope you found it, you know, I hope you're inspired by what Sentinel can do, and go out there and secure your environments.
Thank you so much, Paul. It was an excellent session.
Thank you so much. Thanks, everybody.